This is my final CharlieClock prototype. It uses the concept of charlieplexing to control a large amount of outputs with very few inputs, much more efficiently than traditional multiplexing. Traditional multiplexing uses 2n inputs to control n squared outputs. This means that for 12 inputs, you get 36 outputs. Charlieplexing uses n inputs to control n times n minus 1 outputs, meaning that for 12 inputs, you get 132 outputs, exactly the number of hours, minutes, and seconds put together on a clock. This is because you use every possible permutation of the input pins, and to prevent extra unwanted LEDs from being turned on, a third state is used called high impedance, along with the traditional high and low, power and ground, where when a pin is high in impedance, current cannot flow in or out of that input. And in the case of an Arduino, this looks like setting the pin to an input pin mode. This prevents any LED connected to that pin from turning on, even if its other side is grounded or powered. The clock keeps track of time with a DS1307 RTC, or real-time clock, which is connected to the Atmega through an I2C bus. And it keeps track of time using its own external crystal oscillator. It also has an external 3.3 volt battery in the case, which allows it to keep track of time even when the main source of power for the circuit is disconnected. This is also an alarm clock. You can set the alarm when the switch is in one position, toggle it on and off with that switch, and snooze it for the standard 9 minutes with this snooze button. Which, fun fact, comes from an old engineering restriction due to gear ratios. When the alarm is toggled off, you can set the time instead by holding down that snooze button and using the minute and hour buttons here or on the back of the case. The rate at which the time is set even increases as you keep holding them down. Or at least it did. To address the elephant in the room, the clock doesn't work. It worked briefly before I accidentally shorted the microcontroller on the PCB by, I believe, connecting 2 different 5-volt power sources at once. Embarrassingly, my breadboard prototype doesn't work anymore either, as this Arduino Nano has started acting up just very, very recently, and I'm not sure exactly why. Both of these iterations of the projects did work at one point, although unfortunately I have very little to show for it, except for a very short video of the clock ticking a few seconds on the old breadboard prototype. But I suppose you live and you learn, and you take videos of your projects in a working state. I still enjoyed this project a lot, and I have more to show for the next one, hopefully.